All right, so we are looking at section 3.2. We are going to spend 2 days on this. It covers 2 different methods for solving systems. Today's focus will be solving them with substitution. Have you heard of that term before? Solving a system by substitution? Okay, we're going to look at some different things that can happen. In your notes yesterday, you had a section where it asked you to classify the system. All right. What's going to happen if we have parallel lines and we try to find the point of intersection? We can't, right? There's not going to be a solution here. What if we have 2 intersecting lines? How many solutions will we have? 1 right here. Okay. And then what's the third option? We have 2 of the same line, 2 different equations, but when we graph it, they land on the same spots, right? That means every point on the first line is also going to be a point on the second line. So it's not that every different point works, but we have an infinite number of points that work. Does that make sense? So this point right there is not a solution to that system, but every point on my line would be. Okay? So we have infinitely many solutions in that case. So again, solving by graphing was a nice visual. You could physically see, oh, those 2 lines are parallel. There's never going to be a point where they cross. All right? Our goal is, can we still get that same information algebraically without having to graph them? Okay? So our process for solving by substitution. We need to get one of our equations solved for a variable. It doesn't have to be y. Most people start solving for y just because that's what they're used to doing. But if there's an x that looks easier to solve for, you can do that. But you need one equation that's solved for y. For example, in our first one here, we already have one. Okay? That's already set up. We know what y equals. We can use that in our substitution. Substitution is like making change. You could give me a $5 bill and I could give you 5 ones, right? It looks different. You now have 5 pieces of paper instead of 1, but it has the same value. Okay? So our second step is we need to do a substitution. So we're going to take this value for y and we're going to substitute it into the second equation where there's a y. Okay? So one equation is solved for a variable and then you use that and substitute it into the other equation. What happens when we do that? Instead of that y piece in there, we are substituting in its equivalent, a 2x plus 1. And now notice that there's only one variable left. And you guys know how to solve these equations when there's a single variable, right? So we combine our like terms. We've got 5x plus 1 equals 11, which means 5x would equal 10, which means x has to be 2. We good with that? Okay. The third step, sorry, we just did the third step, solve for the variable. Fourth step, we need to plug that variable, or plug that answer back in and solve for y now. We know that x has to be 2. We can dump it back in. Doesn't matter where you put it. You have to put it in for an x, but I could put it here or here. It doesn't matter. The first one looks a little easier because it's already y equals. Okay, so I'm going to put it there. Y equals 2 times my new answer for x, which we said was a 2. And what do we get for a final answer then? Y equals 5. All right. The way you're going to report your answer to me is as an ordered pair. Because remember, we're trying to find that coordinate point where these 2 lines intersect. Algebraically, we found it to be the coordinate point 2, 5. Okay, remember x is always first, y is always second. The last statement I have up here in our directions is to make sure to check your answer in both equations. It has to work in both, right? It has to be that point that they share. So, on a test, I would expect you to show me that you've checked it. On your homework, I'm going to expect that you check some of them. You don't have to check every single one, but I want you to check enough of them that you know you're doing the process right. Okay, especially on the more complicated systems. We're going to check a couple of them today in our notes, but we won't check every single one. So the work that I would want to see for a check, you're going to take the two equations that you're given, the original equations, and you're going to dump in your x and y's. So for this first one, we have a 2, 5 as our ordered pair. We have y being 5. We have 2 times 2 plus 1. Does that work? Does that work? The two sides match? Okay. The second equation said 3x plus y equals 11. So 3 times our x coordinate plus our y coordinate is supposed to equal 11. Does that work? We get 6 plus 5. Yes? That works as well. So you've showed me that you've checked it in both equations, and it does work. Okay? All right, let's try another one. Do we have one equation already solved for a variable? Yes. So we have y being x minus 4. We're going to dump that in for our x. Okay? Sorry, dump it in for our y. I'm reading it as x minus 4. X minus 4 is going to get replaced where the y was. So we've got 2x plus 3 times our new y coordinate. That's the expression x minus 4. Distributing 2x plus 3x minus 12 equals 7. What do we end up with? 5x equals 19. Doesn't work out nice and pretty, but that's okay. 5x equals 19, so x would be 19/5. All right. Now, we have to substitute that back in to figure out our y coordinate. So y equals this 19/5 minus 4. How do we do that? Common denominator? Okay, 4 would be the same as 20/5. So 19/5 minus 20/5 would be negative 1/5. All right. Ordered pair, remember x is first, y is second. Okay. Questions on that process? All right. Our next example is not solved for y. We don't have to necessarily solve for y. We can pick whichever variable we want. But in this one, there is a nice single y right there. So if we could get that by itself, we can then use that as our substitution. All right, how do we get y by itself? All right, so it ends up being negative 2x plus 1. Okay, now we're going to use that and substitute in here. But notice there's a 3 in front of that y. All I'm doing is I'm taking out the y and replacing it with the new expression. The 3 is still there. So this is going to require some distributing. I'm going to dump in the negative 2x plus 1 in place of where the y was. And now what am I going to distribute? Yes, the negative 3. So I end up with 2x plus 6x minus 3 equals negative 27. Combining like terms, we get 8x minus 3 being negative 27. Adding a 3 over gets me negative 24. And when I divide, I have x being negative 3. Okay? Now, we need to substitute that back in to figure out our y value. We have that y equals negative 2 times x plus 1, and we're substituting in that negative 3. So what do we end up with for y? 7. So ordered pair, my solution is negative 3, 7. Okay. Go ahead and start the next one. All right. This one already had an equation solved for y. So did you make a substitution? That y replacing with 4x? All right. That leaves me 8x minus 2 times 4x equaling 3. But 8x minus 8x is what? So I have 0 x's equaling 3. If I were to solve for x, what would I have to do? I'd have to divide by 0, right? Can I do that? No. 8x minus 8x, the whole side's gone. Think of this as just 0 equaling 3, which is not true. 0 doesn't equal 3. What situation graphically would this represent? I'm not getting a solution. What do we know about those lines? They'd be parallel, right? We have two parallel lines. There's never going to be a place where they intersect. So we're going to say no solution. And the reason behind that is we have parallel lines. Okay? You could take this equation and solve it for y. What would we do? We'd have to subtract the 8x over, right? And divide by a negative 2. So notice that we're getting a slope of 4, which is what we have here, right? We're going to have a different intercept, negative 3/2. So same slopes, different intercepts, parallel lines. Okay? So we don't have to graph it to see that. We solve the system algebraically. We end up with a false statement. The variables are gone, and we have a statement that can't ever be true. Okay? All right. What's different about these next two? We don't have a variable already by itself, right? So we have to do that step. Which one does it make sense to solve for here? The x. Yeah, you have a single x. Get this one solved for x. That means we subtract the 3y to the other side. And now when I make my substitution, where am I going to drop this in? Where that x was. So we've got negative 2 times this new expression, negative 3y plus 5, minus 4y equals negative 5. All right, I'm going to pause the recording. I want you guys to go ahead and solve for y. All right, let's check our work. Did you get 6y minus 10 minus 4y equals negative 5? Combining, we've got 2y minus 10 being negative 5. Adding the 10 over gets us a positive 5, and when we divide, we should have had y being 5/2. Okay, then we're going to dump that back in. So x equals negative 3 times 5/2 plus 5. What do we get for that? Negative 3 times 5/2 would be negative 15/2. The 5, can I write that as 10/2? So we end up with negative 5/2 for x. Okay, check your ordered pair answer. Remember, x has to be first, y has to be second. So you should have negative 5/2, comma, positive 5/2. Okay? I do not want you to leave it as x equals this, y equals that. I want you to show me you understand it's an ordered pair. Okay? It's a point on the coordinate graph. All right. This one's a little bit messier because we don't have a single variable that we can solve for. So it's really your choice. What do you want to do? Solve for y, I heard. Which equation?
I would say solve for y.
First one? Okay. So we're going to take this equation, we're going to solve for y. That means we subtract the 4x over. And then we have to divide everything by 2. So y equals negative 2x plus 9/2. All right. We're going to substitute that in for the y that's right there. we're going to distribute. Distributing gets us negative 6x plus what? 3 times 9 halves. 3 times 9. 27 halves. Okay. Combining like terms, we have negative 10x plus 27 halves equals 16. I'm going to have to subtract the 27 halves from 16. But 16 could be rewritten as what? 32 halves? All right, so let's replace that. With 32 halves. What's 32 halves minus 27 halves? 5 halves? All right. We are going to check your work with fractions. Do not grab a calculator. Do not convert to decimals. Our next step would be to divide by negative 10, correct? How do we take a fraction like 5 halves and divide it by negative 10? Dividing is the same as multiplying by a reciprocal, right? If we think of it in fraction form, this would be negative 10 over 1. So its reciprocal would be negative 1/10. So we can take 5 halves times negative 1/10. What do we get? We can reduce, right? 5 and 10. What do we end up with? Negative 1/4. Okay? That was fun. Now, we have to take that negative 1/4 and dump it in there, right? To get y? So, negative 2x minus 9 halves. Was it minus or plus 9 halves? Plus 9 halves. Okay, so we're going to dump in this negative 1/4 now. More work with fractions. What's negative 2? Or negative 2 over 1 times negative 1 over 4? Becomes positive 2/4, which is 1/2. 1/2 plus 9 halves is 10 halves, which is 5. All right, so x is negative 1/4 and y is 5. Questions on that? That was a big one, but you handled it. All right, last one. It says an online music company offers 15 downloads for $19.75 and 40 downloads for $43.50. Each price includes the same one-time registration fee. What is the cost of each download and the registration fee? We have two unknowns. That means we need two variables. We're going to let x equal the cost of a download. And what would y be? Good. Okay, now, they've given us two different scenarios. In one scenario, we got 15 downloads. In the other one, we got 40. Each of those scenarios is going to create an equation for you. So think about what would your bill be if you did the 15 download option. Okay, we have 15 downloads. Each one of those is going to cost me what? What did we just classify it? The cost of a download is X. So each one of these 15 is going to cost me X dollars. Plus, I have to do what? I have to pay for the registration fee. It's a one-time flat fee. Okay? I have to pay the Y dollars. That's the registration fee. And then they're going to charge me a total of $19.75. Does that make sense? Okay. What's the second scenario? This time I get 40 downloads, but still have to pay that one-time registration fee. Now my bill is $43.50. All right. We have a system of equations. Some books put this brace around it to show that they want you to solve these together. All right. We have our system, 2 variables, 2 equations. Could we solve one of those equations for y? All right. Let's say we use the first one here. What's my new equation going to be? Y equals, good, negative 15x plus the 1975. And then we're going to take that and dump it in here. All right, I'm going to pause the recording. I want you guys to go ahead and solve for both x and y. All right, let's check your work. You've plugged in your y value. So we've replaced that y with the negative 15x plus 19.75. There's nothing to distribute on this one. All right, 40 minus 15x was 25x. If we subtract the 1975 over, what did you get? Was it 2375? And then you divided and you got 0.95? Yes. All right, substituting that back in. So y equals negative 15 times 0.95 plus 19.75. Y ends up being 5.5? Yeah. So in this context, right, x stood for something, y stood for something. All right, so we're going to go ahead and answer the question. Each download costs how much? 95 cents. Here's what I often see when students give me an answer of 95 cents or that type. I see this. You are mixing dollars and cents in the same format, right? We can't do that. We can say 95 cents or we can say $0.95, correct? Yes? Don't mix them. All right, and then registration fee was $5.50. We agree? All right, awesome. So to repeat, our objective was, can you solve a system algebraically using substitution? Yes. How are we feeling about that?
Yes, I can. Ready to dive into homework.
All right, you're ready to dive into homework. That's great. There it is.